Good morning, everyone. Myself Gautam Sharma. I welcome you all in a Sapiens Education. So today I am going to discuss about the part 6 video of magnetism and matter. So in this video we will focus on over the permeability and magnetic characters. So let us discuss one by one. So first of all, I should discuss about the magnetic permeability. What is magnetic permeability? It is the ability of material to permeate the passes of the magnetic line of the pores through it. Let us suppose there are two matter. Okay, this is one material and then another material a and there is another material b. So we have observed that the magnetic field lines can easily pass through this, but there is a hindrance produced in magnetic field lines in the material b. So it means that it has less permeability and it has more permeability. It has more permeability. Okay. So, what do you mean by this? So, it is the ability of the material to permit the passes of the magnetic field lines of the pores through it. So, when material will support, then its permeability is high. So, it is represented by mu. So, more magnetic permeability, more easily magnetic field will pass. Okay, and it is represented by mu. Basically, magnetic permeability is represented by mu. Now, what is relative magnetic permeability? The degree of extent to which the magnetic field can penetrate or permeate a material is called the relative magnetic permeability, and it is represented by mu r. So, relative permeability is the ratio of the permeability of material mu to the magnetic permeability in a free space. So, let us consider this is a relative permeability. So, this will be mu by mu naught, where mu consider this is the material and there is a free space. So in free space, we have considered magnetic permeability as mu, and in this material, we have considered magnetic permeability as mu. So whenever we will find a ratio of mu by mu naught, so we will get a mu. So mu naught is permeability at free space. Permeability at free space. I hope you have understood this. Now let us go for next. Rel- Relative magnetic permeability, the degree of we have already discussed. Magnetic permeability is the ratio by mu naught permeability of the material, and it is the permeability at the free space. Now mu naught has a value 4 pi into 10 to the power minus 7 Weber per ampere per meter, and mu r relative permeability has no unit and no dimension. It is only a numerical value. For air, relative permeability is 1, and for soft iron, relative permeability is high. It means that soft iron will have high permeability, so we should always use soft iron so that it can permeate the magnetic field very high. Okay, now this is your magnetic material. This is your magnetic material, and B naught is the external magnetic field. So total magnetic field inside this will be B. Why B? Because it has increased externally it has magnetic field B naught, and internally its magnetic field is B. It means either it may be decrease or increase. So relative magnetic permeability can be also written as B by B naught. We have already done mu by mu naught as a relative permeability, or we can also write relative permeability as a magnetic field inside the material divided by magnetic field outside the material in a space. So this is one of the formula. Now let us go for next one, classification of substance according to mu r. So there are two types of substance, that is non-magnetic substance and there is magnetic substance. In non-magnetic substance, relative permeability are always 1. For example, air, cotton, glass, wood, plastic, mica, rubber. But in magnetic substance, mu r is not equal to 1. It will be greater than 1. Now, magnetic substance, it can be categorized. See here, it may be greater than 1 or less than 1, but it can't be 1. Now, we will also categorize subparts of the magnetic substance, that is diamagnetic. So, mu r is less than 1. So, antimony, bismuth, copper, quartz, water, etc. Paramagnetic. Paramagnetic material, the magnetic material having a relative permeability greater than 1, and aluminum, chromium, manganese, lithium penetration. But what about the ferromagnetic? Ferromagnetic will be very high. If relative permeability is like approximately 8,000, so it is definitely very high and far from 1. And the material come under this is your iron, cobalt, nickel, and their alloys. Okay, I hope you have understood this. Now, magnetizing force or magnetic intensity. So, magnetizing force or magnetic intensity. Let us consider this is a magnetic material having a magnetic field inside B and outside is B naught. The degree to which the magnetic field can be magnetized is represented in terms of a magnetizing force or magnetic intensity. So, the degree in which it can be magnetized, it means that it can be made as a magnetic material, and it is known as magnetic intensity, and it is represented by H. It is represented by basically H. Now, magnetizing force of magnetic intensity can also be written as B naught, that is external magnetic field mu naught. So, H magnetic field intensity is equal to B naught by mu naught. Now, magnetic field intensity can also be written as B by mu. If you use B naught, that is without in external, so we have to use permeability as mu naught. Means basically what we need to do, we need to find a ratio of the permeability. For example, permeability of outer one is mu and permeability of inside is mu and outer is mu naught. So here magnetic intensity will be H is equal to B naught by mu naught. But if you talk about this one, so this will be H is equal to B by mu naught. Okay, so I hope you have understood this. Now the SI unit of H is ampere per meter. So this you need to understand. Now magnetization intensity. Magnetic. Let us suppose this is your magnetic material, and external magnetic field is B naught. So magnetization depend upon the nature of the material. First of all, how much it depends upon nature of the material. It represents the extent to which the material can be magnetized. It means that it will behave. Let us consider there is a iron or a no, iron or a nickel. So it will behave as how much it will behave. So it represents the extent to which the material can be magnetized, or it will behave how strongly. And it is represented by I. So more magnetization intensity, more magnetization of the material is there, and it is represented by I. So magnetization I, the magnetization intensity of a magnetic material is defined as the magnetic moment per unit volume. So let us consider magnetic moment of this one is m and b is this. So I is equal to m by p. We can consider it. Okay. So I hope you have understood this. Now magnetization intensity I is equal to m by 2L. So we know that m, that is dipole moment, is equal to m into 2L, and volume is equal to area by 2L. So if we put here, so this is your magnetization intensity. This will be equal to m by. So magnetization intensity of a material is also defined as the pole strength per unit area of the cross section. So this is very important formula. Pole strength per unit cross section area is known as magnetization intensity. Okay. So I hope you have understood. If you have not understood, pause the video and again you see that. Magnetization intensity can also be written as Bm by mu naught, where Bm is the magnetized form of magnetic field and divided by mu naught. So Magnetization intensity can also be written as Bm by mu naught. Now let us go for a magnetic susceptibility. It is the property which determines how easily a material can be magnetized. If it has more magnetic susceptibility means more easy to magnetize. Susceptibility of a magnetic material is defined as the ratio of intensity of the magnetization induced in the material to the magnetizing force applied. That is, xm is equal to I by h. If less force is required for magnetization, then it will be high. If more intensity is required, so it will be high. So magnetic susceptibility is represented by xm, and it can also be written as I by h. It can also be written as I by h. So I hope you have understood this. Now relation between permeability and magnetic susceptibility. Now let us suppose this is a magnetic material and this is your magnetic field. Now when a magnetic material is placed in a magnetic field, a magnetic intensity H and a material getting magnetized. So let us suppose I is the magnetization intensity and H is the magnetic intensity of this. So we know that B naught is equal to mu naught into H, and also B is equal to mu by H, and Bm is equal to mu naught into I. So these three things 1, 2 and 3 earlier we have discussed. Now B is equal to also B naught plus Bm. Okay, B total Bm magnetic field is equal to B naught plus Bm. Now we will put the value. So when you put here mu naught H is equal to mu H is equal to mu naught H plus mu naught I. So just dividing mu naught H, we get this mu by mu naught 1 plus I by H. So mu by mu naught is known as relative permeability. That is relative permeability. It is written. One is written, and I by H is also known as xm. That is susceptibility. So from here we can get this is the relation between the relative magnetic permeability and the magnetic susceptibility of the material. Okay, I hope you have understood this all derivation. So this is very important. You need to understand susceptibility plus 1 is equal to relative permeability. So I hope you have understood this. So for this is enough for today. So in next class, I will discuss about the diamagnetic material property. Thank you.